Hello students, let us look at the standard form of a parabola. This is also the equation of the parabola in its simplest form. In this form, the axis of the parabola is along x-axis. The axis is along x-axis. In fact, the axis coincides with the x-axis, and the directrix is parallel to y-axis. Okay, so the directrix is taken parallel to y-axis. Okay, so this is the directrix here, and this horizontal line is our axis and also the x-axis. Okay, now P is a point in this plane which is tracing this curve. Okay, and let's take a point on x-axis, let's say right here. So this is our focus. The coordinates of the point which is in motion are x and y, so they change. And in order to get the coordinates of the focus, this is what is done. Okay, the point where the x-axis cuts the directrix, it is usually denoted by z, and this zs is divided into two parts. Okay, so we take a point here, we call that as A, and this zs is divided into two parts. Okay, so these two are equal. Okay, za is equal to as. Now if you draw a perpendicular line through A, that line is taken as the y-axis. Okay, so here the blue line that we are looking at, this is our y-axis. Okay, and as a convention, the distance between Z and A and S is considered A. Okay, so this is the parameter, so this is A. Okay, now if I join the points S and P, the focus and P, okay, since I know the coordinates of S and P, I can get the distance between S and P. So what are the coordinates of the focus here? If this is A is taken as the origin now. Okay, A is also known as vertex. Okay, so A is known as vertex, and that is our origin. A is the origin. So you can say that A is the origin. So it has coordinates 0, 0, and then the coordinates of S are A, 0. Okay, so we can get the distance between S and P using the distance formula. And then if I draw a perpendicular from P to the directrix. Okay, so if I draw a perpendicular from P to the directrix. Okay, so let me draw it slightly better. Okay, I think that is okay. So the foot of the perpendicular, usually letter M is used to denote it. And we know from the definition of the parabola, the distance from the focus is equal to the distance, perpendicular distance of P to the directrix. Okay, so here SP is equal to PM. Okay, and if I square these two, I have square of SP is equal to square of PM. Okay, now since I know the 2 points S and P, the square of the distance can be written very easily. So what do we have here? X minus A whole square plus Y minus 0 whole square. And it is very easy to look at the distance PM here. So if you take from the origin, or maybe start from the directrix, Z to A is A. Okay, Z to A is this distance A. A is the origin. So if I drop a perpendicular from P to the x-axis, let's call this as N. Now this distance is clearly the x coordinate of point P, which is simply x. So PM is basically A plus x. So we can substitute that here, A plus x, and we are squaring here, so A square. So now open up on either side. Okay, so expand and then open up. So what do we have here? X square plus a square minus 2ax, and this is simply y square. On the right hand side, we have a square plus x square plus 2ax. And if you look at y square, we can keep y square on the left hand side. This minus 2x can be sent to the other side, and then you should observe that we can ignore these x squares on either side, a square on either side, and then we simply have y square equal to 4ax. Okay, so this is the equation of the parabola in its simplest form. Okay, in its simplest form. We have not shown the curve of the parabola yet. I will do that in a minute. But this is the one which we will use more frequently, y square equal to 4ax. So here we have to understand again that the axis of the parabola is along x-axis and the directrix is parallel to y-axis. Okay, now if you are trying to get the equation of the directrix, that can be done very easily here. So the coordinate of z is minus a comma 0. So this line, the directrix, is simply given by x is equal to minus a, or you can write this as x plus a equal to 0. So this is one thing that we can keep in mind. Okay, another thing, geometrically, if you look at the diagram here, this y square is nothing but the length of this perpendicular from P to x axis. So you're basically saying the square of that perpendicular is 4 times the distance of the focus from the origin AS multiplied by the x coordinate, which is AN. Okay, so this is something that maybe you can keep this in mind. Okay, so now let us trace this simple form of parabola. Y square is equal to 4ax. I'm going to take let's say few points to do this. To begin with, the origin is A, the vertex of the parabola. This is x-axis and this is y-axis, and this is our vertex at a distance A from the let's say origin. And then we need to understand this y. We have divided the distance between the directrix and the focus into two equal parts. Okay, so if you take a look at this point A, this is going to be on the parabola. Okay, so because the distance of point A from the focus is equal to its distance from the directrix. So A is bound to be on the parabola. Okay, so this is the vertex and this is our directrix. Okay, so if I take few points, okay, so x and y coordinates. If x is 0, y is clearly 0. So we have a vertex there. Okay, so let's say I'm trying to get the values of x in terms of this parameter called a. Okay, so this is where we have the focus. Okay, so let's take, this is a and 2a, maybe 3a and 4a. Then again, so let's take these values in terms of a. Okay, so if I take a, x as a, okay, y square is 4a square, and then we'll get plus or minus 2a. So we can plot these 2 points. When x is a, the y values are plus 2a and then minus 2a. Okay, so this is plus 2a and this is minus 2a. Suppose if I take x as 4a, okay, you have 4a into 4a, so we'll end up having plus or minus 4a. So let's say we can show them here. So this is 1, 2, 3, 4. So this is 4a, and then we have these 2 points. Okay, so this is plus 4a and then this is minus 4a. And if I take negative values for x, okay, and then when you're trying to get the square root of a negative value, we know those are imaginary values. So we should not have the curve shown to the left of y-axis. Okay, so for negative values of x, there are no y values. Okay, so we can ignore the left side of the y-axis. And then if I roughly plot these points, okay, so if I plot these points, again, I know I'm not showing you the points in between, but trust me, so the parabola looks something like this. Okay, so it kind of goes till infinity. As x value increases, the y values continuously increase, and then these two portions of the curve, obviously, they're not going to meet, so they're going to kind of diverge. Okay, so this is how roughly the graph of the parabola looks like. And again, we are still looking at a very standard form of the parabola.